Additionally, the James Webb Space Telescope, JWST, also known as Webb, is a scientific explorer that has uncovered amazing information about stars, galaxies, planets, and other cosmic phenomena. In a similar way that it has created Webb standards for scientific research, it is praised as the legendary Hubble Space Telescope. People from all over the world have accessed the telescope, sharing photos or using raw data to create fresh insights. A year has passed since the formidable James Webb Space Telescope revealed its first-ever image of the universe, surprising astronomers around the world with its incredible level of detail. However, its current discovery is a striking representation of the universe we've never seen before. Prior to what has been discovered thus far, the James Webb Space Telescope's images raise more questions than they answer. Scientists continue to investigate how the most astonishing photographs ever captured by the telescope challenge our understanding of space. As the Hubble successor, the telescope has unveiled new data about star formation, galaxy mergers, and the early cosmos. 1 month after the first images were made public, they were breathtaking, showing the entire universe in stunning detail. Since then, the number of discoveries has skyrocketed, providing scientists with a priceless treasure trove of information. The James Webb Space Telescope has observed cosmic phenomena, including record-breaking space smoke from the Tarantula Nebula, stars on the verge of exploding, and other exceptional celestial objects. This satellite observatory's cutting-edge technology allows us to see farther into space than ever before, revealing previously unknown details about the cosmos. A new era in astronomy has dawned, thanks to the telescope's precise and detailed images. To commemorate the first year of the James Webb Space Telescope's operation, NASA released an image showing a tiny region within the structure of the Rho-Ophiuchi cloud complex. The picture shows new stars bursting into jets as cosmic dust clouds of diverse colors collide. Molecular hydrogen makes up the purple dust, and the presence of a circumstellar disk casts a shadow on a few stars, pointing to the possibility of planet formation. While the photo may depict cosmic mayhem, NASA states that this stellar nursery is relatively tiny and peaceful compared to others. Additionally, numerous young stars in the area are about the same size as our Sun or even smaller, making it the closest star-forming region to Earth. The observatory's main camera, the Near-Infrared Camera, NIR-CAM, captured this stunning image. The telescope's ability to observe in the infrared spectrum has significantly improved our comprehension of exoplanets, worlds that orbit stars other than our Sun. James Webb is particularly adept at observing large, distant galaxies. The first exoplanet observed by the telescope, LHS 475b, was detected at the beginning of 2023. The planet is 41 light-years away and has a diameter comparable to Earth's. According to NASA, the James Webb Space Telescope is the only operational telescope capable of categorizing the atmospheres of Earth-sized exoplanets. The findings demonstrated how precise Webb's exoplanet observations are, opening a new frontier for astronomers to investigate. Following this, the telescope found evidence of long-known galaxies that, from a theoretical standpoint, should not exist. A team led by astronomer Evo Lab of Swinburne University, along with an international group of researchers, observed 6 giant, universe-spanning galaxies from the early cosmos. These enormous galaxies, which may have formed between 500 and 700 million years after the Big Bang, could completely change our understanding of space. Using Webb's advanced instruments, scientists can glimpse back in time about 13.5 billion years, when stars and galaxies were much younger. The discovery has left scientists bewildered, as galaxies in the early universe should have been 10 to 100 times smaller than these. According to calculations, these 6 objects may be billions of times heavier than the sum of all the stars in our solar system. Just one galaxy is likely 100 billion times heavier than our Sun. The sheer magnitude of these findings challenges existing theories of galaxy formation. Most galaxies from this era are thought to be small and only gradually increasing in size. However, some monstrous galaxies appear to have grown at an accelerated rate. It remains uncertain what caused this rapid growth or how it functioned. Penn State University assistant professor and co-author of the study, Leah Juvel, expressed surprise at the discovery of a new class of massive galaxies forming during the early universe. This finding challenges many prior perceptions of cosmic evolution. It is so extraordinary that it has forced the scientific community to reconsider fundamental ideas about how galaxies formed in the early universe. Galaxies from this epoch are considered infants because they are still developing their structure. However, Some galaxies in the early cosmos appear as old as our own, contradicting previous assumptions. Spectroscopy, breaking down light into distinct wavelengths, permits precise distance measurements, which are required to verify these findings. Scientists are currently working to confirm the accuracy of the data, as only a handful of these recently discovered objects have undergone rigorous mass and distance testing. If these discoveries hold true, galaxy formation would have needed to be significantly more efficient and rapid than previously thought. Spectroscopic analysis has provided promising results that support the images captured by Webb. For decades, scientists have tried to decode the history of the universe, and Webb may hold the key to answering some of the biggest questions in cosmology. However, conflicting data from telescopes sometimes leads to gaps in understanding. Dr. Katie Mack, a cosmologist, has offered insights into the situation, explaining how JWST's discoveries could challenge long-held theories. Webb has provided evidence of galaxies forming much earlier than expected. But, as Mack noted, astronomers shouldn't worry about their models just yet. The telescope is capturing images of galaxies over 13 billion light-years away, meaning they appear blurry and distant. There may not have been enough time since the Big Bang for such massive galaxies to have fully formed, according to current cosmological timelines. Some scientists worry that these findings could challenge theories about dark matter and the Big Bang itself. However, further investigation is required before drawing conclusions. Webb captures stunning views of nearby nebulae, but distant galaxies appear as faint, fuzzy dots. This is due to the way colors are influenced by different wavelengths of light. Webb detects light in two ways: through spectroscopic analysis, which spreads light into its individual wavelengths, and through filters that isolate specific color ranges. By analyzing the redshift of galaxies, scientists can determine their distance and age, offering deeper insights into the evolution of the cosmos. Certainly. Here's the continuation of your text with proper punctuation and clarity. Redshift measurements allow astronomers to determine how far away a galaxy is and how much the universe has expanded since the light left that galaxy. By comparing this redshift data with theoretical models, scientists can refine their understanding of cosmic evolution. However, the unexpected presence of massive, mature galaxies so early in the universe's history remains a profound mystery. If these galaxies truly formed only 500 to 700 million years after the Big Bang, it suggests that galaxy formation was not only far more rapid but also more complex than previously thought. This could challenge existing models of dark matter, star formation, and the very nature of cosmic expansion. Some researchers speculate that there may be unknown processes at play, possibly new physics that has yet to be discovered. Meanwhile, astronomers are using JWST's powerful instruments to probe deeper into the nature of exoplanets. The telescope has already detected water vapor, carbon dioxide, and methane in the atmospheres of distant worlds, providing crucial insights into their potential habitability. These breakthroughs bring scientists one step closer to answering one of humanity's biggest questions: are we alone in the universe? Beyond exoplanets and galaxy formation, Webb's observations are also shedding light on the mysterious dark universe. By analyzing gravitational lensing, where massive celestial objects bend light from distant galaxies, scientists can map dark matter distribution with unprecedented accuracy. These studies could help unravel the nature of dark matter, which makes up most of the universe's mass but has never been directly observed. As the James Webb Space Telescope continues to push the boundaries of scientific discovery, it is clear that we are entering a new era of astronomy. The telescope's extraordinary capabilities allow us to witness the universe as never before, capturing breathtaking images that redefine our understanding of space and time. With each new revelation, JWST challenges our theories and inspires new questions, proving that the quest for knowledge is far from over. The discoveries made by this revolutionary observatory will undoubtedly shape the future of astronomy, physics, and our understanding of the cosmos for generations to come. Data with spectra predicted for galaxies with characteristics similar to this redshift tells us the exact point in the history of the universe. As we see it, many galaxies appear to have an excess of stars or stars that were too young when they would have lived, according to comparisons of model spectra. There are a number of possible causes for this. The photometric readings could have been off due to issues with the telescope's calibration, or they might have been found in a group of galaxies that is not representative of the norm or very small regions of the sky. Another possibility is that galaxy spectra models, which are designed for closer galaxies, do not work well with galaxies farther away. On the other hand, cosmologists may have to deal with the exciting prospect of having to rethink cosmic evolution. If those galaxies are indeed extremely large, and earlier estimations were wrong, then we must reconsider our understanding. However, this is hardly the only place where scientists have fallen short despite technological progress. Planets that are simply too extensive have astonished experts, none more so than the discovery of a planet that is thought to be too huge for its star. This has led to a re-evaluation of our collective understanding of planet creation and solar system architecture. Additionally, the models that astronomers created in the period following the discovery of a planet 13 times as large as Earth, in a system of planets centered on the ultra-cool dwarf star LHS 3154, have changed our perspective. A 9 times larger star, smaller in size than our Sun, according to a news statement, has a mass ratio 100 times greater than Earth's ratio to the Sun prior to the most recent observations. Scientists didn't think such a scenario was feasible, but new evidence shows that the largest planet in our solar system is indeed orbiting one of the smallest and coolest things in the universe, an ultra-cool dwarf star. We still know very little about the cosmos, and this discovery proves it even more. A planet of this mass orbiting a star with such a low mass defies our expectations. These stars may have originated in large gas and dust clouds, and planets may have arisen from the gas and dust that remained in the disk of material surrounding the newborn star. However, it was not anticipated that the disk forming the planet around the low-mass star LHS 3154 would include sufficient solid mass to produce this planet. But since it exists, we must now reconsider our theories concerning stellar and planetary formation. A good illustration would be to contrast the star to a campfire. In order to maintain your body temperature, you must move closer to the fire because its heat decreases with distance. Planets are no different. Gravitational forces pull on planets in the same way we would feel warmth from a fire. The Earth, for example, needs to be much closer to its star to gain enough gravity to maintain its orbit. Since a low-mass star cools much more quickly than a star of greater mass, our understanding of planetary formation and evolution may need to be revised in light of this discovery. This massive planet, found orbiting a low-mass star previously thought incapable of hosting such a planet, challenges existing theories. Although researchers have discovered planets with diameters up to 12 times that of Jupiter, the more we learn about space, the more we are forced to reconsider what we previously thought to be true. Astronomers have always aimed to comprehend how everything works in space, and the James Webb Space Telescope, JWST, may eventually provide the missing components. Right now, the JWST is observing Jupiter's moon, Europa, for signs of life in our solar system. The second Galilean satellite has long been considered one of the most likely places to host life beyond Earth. Although it is icy, scientists believe there is a large subterranean ocean beneath it. The ice shell of Europa is even more intriguing, featuring shattered surfaces, fractures, and an environment akin to the Arctic. Additionally, massive plumes of water vapor emerge from the ice shell. Scientists believe the ocean beneath is the source of these plumes. Using the infrared capabilities of the JWST, scientists will analyze the surface properties and chemical makeup of Europa in detail. Given the opportunity to search for chemical signatures of life, JWST may be able to detect plumes erupting from the surface. As astronomers continue to explore Europa's fascinating chemistry, the JWST is expected to yield numerous additional, unexpected discoveries. The James Webb Space Telescope, JWST, has revolutionized our understanding of the universe with its unparalleled observations of galaxies, stars, and planets. As the successor to the Hubble Space Telescope, JWST has provided the scientific community with an extraordinary tool for exploration. People around the world are sharing its images and evaluating raw data to generate new insights. Since its first historic image was revealed last year, JWST has continued to astonish astronomers with its precise observations. One of the most recent images presents a hauntingly beautiful view of the cosmos, leaving scientists with more questions than answers. Just 1 month after its initial images were released, JWST revealed new details about galaxy mergers and star formation in the early universe. These pictures offer a breathtakingly clear view of the cosmos. Since then, discoveries have multiplied, providing an enormous store of information. Documented observations include cosmic record-breaking space phenomena, such as smoke from the Tarantula Nebula, stars on the verge of collapse into supernova explosions, and other extraordinary celestial objects. The telescope's cutting-edge technology allows us to peer deeper into space than ever before, unveiling previously hidden details about the cosmos. To celebrate its first year of operation, NASA released an image of a small star-forming region within the Rho-Ophiuchi cloud complex. This picture shows jets erupting from newborn stars amidst vibrant purple cosmic dust. Molecular hydrogen in the dust casts shadows on several stars, hinting at the presence of circumstellar disks, potential indicators of planetary formation.